Okay, so this is the mock hire question number 3. Part of the journey of a car is shown by the graph below. So we can see that this is a time velocity graph. So here we've got the start of the journey, and the journey lasts for 80 seconds. On the side here we've got the velocity measured in meters per second, or the speed. So we can see that over the first 30 seconds the vehicle increases in velocity from 0 meters per second to 60 meters per second, 60 meters per second. For the following 35 seconds it travels at a constant velocity before decelerating back down to 0 meters per second at the end of the journey. Okay, so use information from page 2 to calculate the total distance travelled by the car. Okay, so the total distance, if we look back at the equations, is going to be given. Okay, so if we look down the list, we're looking for total distance. Distance travelled is the area under a velocity time graph. Okay, so it's not an equation as such, it's a little bit of work that we have to do to work that out. Okay, so if we have a look at this graph, we can break this graph into 3 main parts. Okay, so we've got this part here, which is a triangle. Okay, and this triangle has a base of 30 and a height of 60. And if we use the equation, the area of a triangle is half base times height. Okay, so we've got 30 times 60 times a half is the area under that first part of the graph. So if we put that into a calculator, it gives us 30 times 60 times 0.5, which is the half. So that's 900 meters for that part of the journey. The second part of the journey is a simple rectangle. Okay, and the area of a rectangle is the width of the base times the height. We stick to the same ideas. So we've got from 30 there to 65. So that is obviously 35 seconds times the height, which again is 60. Okay, so 35 times 60 is 2,100. And then the final part of the triangle here, we've got a base of 15 and a height of 60 again. So that's 15 times 60 times a half, because it's a triangle, half base times height. So that's 15 times 60 times 0.5, which is 450. And if we add those 3 values together, this comes to 3,000, so 3,450, 3,450 meters, or 3.45 kilometers. Okay, which for a car journey over a minute and a bit is reasonable. Okay. The next question says, a passenger in the car has a mass of 70 kilograms. Discuss how the resultant force on the passenger changes through the 80 seconds of the journey. Include in your answer calculations to show the resultant force on the passenger at different stages in the journey, an explanation of how the resultant force affects the motion of the passenger at all stages. Okay, so we have a brief discussion and then I'll refer to the official mark scheme. So we can see here that we've got an acceleration, okay, because we're going from 0 to 60 meters per second. And if we look at the front of the book, we'll find that the acceleration can be calculated by dividing the change in acceleration by the time over which that takes. Okay, so the change in acceleration is going to be 60, take away a 0, which of course is 60, divided by 30 seconds. Okay, so that's 60 meters per second is the change in acceleration, divided by 30, that is seconds, and that's going to give us 2 meters per second squared. Okay, so that's an acceleration. The force that exerts on the person we could use the equation F equals ma. Okay, that's force is mass times acceleration, and we're told in the question that the passenger is 70 kilograms, and we've just calculated the acceleration as 2 meters per second. So the force in this part of the journey is 70 kilograms times 2 meters per second squared. Okay, so the force is going to be 140, and because it's a force, that's going to be newtons. So that's the initial part of the journey. And the central part of the journey here, there is no acceleration, therefore the passenger would feel no force really, it's constant velocity. And then the latter part of the journey, we've got a deceleration, okay? And so the deceleration, again, is going to be the change in velocity, and the change in velocity is the same because it's from 60 down to 0, okay? But this time, the time over which that happens is shorter, okay, and it happens over only 15 seconds. That would give us a deceleration of 4 meters per second. So we could say that's minus 4 meters per second because it's a deceleration. And then again, we could use the F equals ma equation to work out the force that that person would encounter. And again, they won't have changed mass a great deal, and that would be by 4 meters per second squared. Okay, and that's going to be twice the initial, the other force, so it's going to be 280 newtons. Okay, so those are the sorts of calculations and the sorts of ideas that they're looking for. But if we refer to the official mark scheme to see the sorts of things we were looking for. So as previously, we've got these this indicative content. So it says in the first 30 seconds, there is a resultant force acting in the forward direction, which makes the passenger accelerate. Calculations to show the acceleration is 2 meters per second squared, and the force is 140 newtons. Okay, between 30 seconds and 65 seconds, the speed is constant, so the force is 0, the resultant force is 0. And then for the last 15 seconds, there is a resultant force opposite or backward, causing the passenger to decelerate to 0. And you need the calculations to show the deceleration is 4 meters per second, so the force is 280 newtons. Okay, so that's in words effectively what we've just been talking about in numbers. In order to get the full marks, the top marks, you need to put all that all together in an articulate, integrated account. In other words, it's written well and it all makes sense. And you do it in a sequential manner, and you make sure that you don't leave anything out, and that you use the right terminology and it's well written. For 3 to 4 marks, and you can imagine it's a lower quality answer, maybe some things missed out, maybe the way in which you address the answer isn't clear, isn't using all the correct terminology. And then for 1 to 2 marks, you've obviously understand something about what you're saying, but you've not written it in a very coherent manner, and your scientific terminology and your spelling and punctuation, etc., are poor. Okay, so that's the sort of thing we're after there. Okay.